Hi, I'm Tim Habel with Garage Gurus, and welcome to our first Facebook live stream. I'm here with our team members to help me get through the stream tonight and field some questions from you so that this can be an interactive experience. Tonight's topic is to discuss LS head gasket installation tips. So we're going to go through a lot of different key, important discussions about the best way to service head gaskets, not only on the LS engine, but just in general. So if you have any questions as I walk through this process, be sure to drop them below in the comments and we'll be sure to answer them. Okay, so tonight, what I want to talk about specifically with the LS engine is that with over 2.5 million of these engines out on the road today, it'll be likely that you'll experience this very common repair problem that occurs. And what that is it has to do with the camshaft and the lifters. Now I know tonight we're not talking about camshafts and lifters, but in order to service the camshaft and the lifters on this particular engine, you have to remove the cylinder head in order to get to the lifter buckets that retain the actual valve lifters. So in order to pull these out of the engine, it is important obviously to take the head off. So what happens with this very common failure is typically a vehicle owner tends to start to hear a chirping or a squealing from out under the hood. Almost sounds like a belt squeal. And what that is it's the beginning of the lifter roller beginning to gall and quit rolling. So as it seizes, it basically drags on the cam lobe. And you can see with this example that the cam lobe on this engine, and of course the roller on the end of this valve lifter, is completely separated and the needle bearings are gone and the cam lobe is damaged. So in order to service this component, we've got some major engine work to do on this engine, which is going to lead to the replacement of the head gaskets. Okay, so I've got a live engine here that I'm going to go ahead and pull the cylinder head off of. I've just got 2 bolts left retaining it. What I want to talk about is what you would face in working on a live engine doing this repair. So when we get the cylinder head off the engine, one of the things that we first want to be aware of is discarding the original bolts. We'll talk more about this later, but these bolts have a one-time use. They're basically called the torque to yield bolt. And once we pull these off, they go in the trash can. There is no reusing these particular bolts. With the bolts off, we can remove the cylinder head. And as we examine the components, you can see there's a lot of cleanup to be done. A lot of carbon to remove, a lot of gasket residue, maybe coolant residue, both on the head itself and of course the engine block. So we're going to have to clean this surface up, and there's a lot of different ways to do it. Some are the right way and some are the ways that we really don't want to do that can lead to more problems down the road. So as you can see, we can pull the original head gasket off, and we'd also want to inspect, maybe look for carbon leaks, maybe from the combustion seal failing, look for coolant leaks from maybe where we've got coolant migrating outside the gasket, leaking externally. Those are all kinds of failures that you could expect to see if it was head gasket related. In this case, our gasket looks pretty good. We're just in here to service the camshaft and the lifters. Okay, so when we talk about cleaning cylinder heads, I mentioned there's a few different tools and methods that we can use. So the first one that I'd like to show you kind of stems around using power tools. Now, a lot of technicians like to go about this method because it's fast, it is productive in terms of cleaning the surface, but it typically causes us more harm than it does good. So I want to show you a couple of examples here. Put my safety glasses on, and now I can go ahead and take a 3M bristle pad, which has these little rubber fingers on there. Now, these are very common tools used in the trade, but you need to be aware of that there's multiple types. And some of these are different colors, which mean they have different grits. I'm okay, I'm going to go ahead and use these here. So the green one that I just dropped on the ground is a 50 grit. It's very abrasive. It definitely doesn't have a home on an aluminum component, like an aluminum cylinder head. The yellow is a little more forgiving. It's an 80 grit, and then the white one is 120 grit, which is commonly used on aluminum surfaces, but we just don't want to use it to clean up a cylinder head. So I want to show you why. So you can see here that as I use that on the head surface, it creates a lot of lines on top of the deck of the head. And those lines, although they're microscopic, they are ridges in the head, which make it not flat. And those areas can cause the head gasket to fail. So basically, using these abrasive tools, although they're very fast and very productive, they create a lot of damage on the head surface. So I've got a question coming in here from Kyle in Cleveland. And Kyle asks, what is the best procedure for cleaning the head gasket surfaces? Kyle, that's a great question, and I'm going to get there in just a minute. The thing I want to talk about with the power tool real quick before changing gears and showing you the proper method for cleanup is another common tool that's used is what's commonly referred to as the cookie wheel, which is a Scotch-Brite style pad, scrubber pad, that goes on a die grinding tool, very much like the 3M bristle fingers. And you can take this over to the surface. It works in very similar principle to the rubber fingers, but you can see it's a little bit more abrasive on the deck of the head than those rubber fingers were, the bristle pads. So again, this is definitely a tool, although effective at removing residue, it's horrible for damaging our surface, and we want to avoid using this kind of tool. So to get back to Kyle's question is, what is the proper method? In most cases, and not everyone likes to hear this, but the best method is to use something that's forgiving to the surface of the head and even the deck of the block, which also needs to be cleaned. So it kind of gets back to a very manual process using either plastic razor blades or specific gasket scrapers that are plastic. And the reason behind the plastic is that it's pretty forgiving on an aluminum surface. Obviously the plastic is going to be softer than the aluminum casting, which will prevent us from using a traditional gasket scraper that can gouge and leave behind deep troughs and valleys in the casting. Not a good thing. To kind of aid with some of the cleaning on the cylinder head, we can use chemicals to help us with that, like this gasket remover. And if you read the directions on these cans, they often require that you spray a little onto the surface, give it 5 or 10 minutes to kind of soften up the residue left behind from the old gasket, and then come in with the plastic or even wooden scraper and just kind of scrape off some of that residue. And that works really well. So again, very tedious, certainly not as fast as using the Scotch-Brites or the rubber bristle discs, but it is a much safer method in order to be able to install this cylinder head back onto the block without any machining. Now, machining brings up a great question because in some cases, what really is the best method to prepare the cylinder head for reinstallation is to send the head off to a machine shop and have the machine shop basically surface grind or mill the surface of the head, which creates a very fine finish. Typically we're looking for something under 30 RA in the milling of a cylinder head so that we have the right surface for what this engine requires, which is an MLS gasket. And I'll talk about that in just a couple more minutes. But the other thing that milling the cylinder head will do for us is ensure that the casting is flat from end to end, which is just as important as surface finish. So in this case, we've got to head back for our rebuilt engine that we're going to go ahead and go through the process of installing a new gasket on essentially a rebuilt engine that has a freshly machined deck. We've got a freshly machined cylinder head, so as long as these two components are completely clean, free of oil, free of grime, we're ready to install our new MLS head gasket. So let me set the head down here for a moment and grab our new Fel-Pro MLS head gasket. And you can see here that this particular multi-layer steel gasket, which is what MLS stands for, already has a coating installed. And the coating on this gasket is there to basically help seal the water ports on the deck of the block as the coolant transfers from the block into the head. The coating on this is very, very thin, which is why the surface finish requirement is as fine as it is. So to put things in perspective, since we talked a little bit about RA, the thing to know about roughness average is it's a measurement of surfaces. So oftentimes we can find these tools out in the trade that are what they call surface comparators, which will give us a really good idea as to how rough the surface is on either our head or our block. These are fairly cheap to get, and they give us a great idea to compare to, you know, our surface if it's sufficient enough for installing a new gasket. And in our case, we know that we've machined the block to achieve a 30 RA or under, which is great. Now, the coatings, as I was referencing on the MLS gaskets, they're very thin, which is why this surface finish has to be so smooth, because with such a thin coating, there's not a lot of ability for the coating to press into the valleys and peaks from the machined surface. So they need to be very, very flat across the top. So when you talk about RA, a good explanation to put things in perspective is if you think about a pane of glass has an RA of about 7. So we're asking in the ideal situations, just like the OEMs, that the surface is 30 RA or less. So that's pretty darn smooth. Very, very hard to achieve, you know, with a cookie disc or a bristle brush. Certainly the plastic scrapers kind of retain the factory surface and keep us from damaging it. So it typically works out pretty well. So we're ready to install this gasket, and the thing to do and remember here is that it goes on clean and dry. So we drop it into place, pop it down on the dowel pins. Very important that the dowel pins in the block are secure. They're going to locate the head as well as locating the gasket. And I see we've got a question here from Eric at Pittsburgh. And Eric asks, does the gasket have to go on any certain way, and do you spray sealer on the gasket? Well, Eric, that's a great question that we commonly get asked on our technical hotline. And the answer is to first address orientation of the gasket. Many times our gaskets will have a marking on them, such as this guy here that says front. When you have a marking such as front, this gasket has to install, obviously, with front to the front of the engine. Now, there are some gasket applications where we may only mark one side of the gasket. This is not a case, because we basically have front on both sides of the gasket, because this is a V-type engine, left and right side. Same part number fits both sides. Not all engines are that way. So when you talk about orientation, as long as we're putting front to the front, whether it's up or down on the gasket does not matter, right? In the case where we mark this only on one side, you invert this gasket onto this side of the engine. Obviously, we're not going to be able to read the words if they're only printed on one side, but it is the proper install. It is to the front of the engine. So in this case, we drop her down. And as far as sealers go, we do not want to add any sealant to this gasket. Part of the coating that we put on the gasket aids in sealing up the water ports, as I mentioned, or on an overhead cam, the oil passages that feed from the block to the head. We definitely don't want to use any additional chemicals. A lot of people like to use a copper coat or Permatex High-Tack. These types of coatings that are sprayed on top of the gasket will only cause us troubles. So clean, dry, flat surface with the proper RA is what we want to achieve. So now that we've set our gasket into place, we're ready to set our cylinder head on, kind of talk about the next step in the process. Very important step. So I mentioned earlier when we remove the cylinder head from this particular engine that the head bolts go in the trash can. Well, that means that we need, you know, new head bolts for this engine. And Fel-Pro supplies new bolts, and we often supply bolts basically ready to drop in and go. And what I mean by that, and oh, by the way, I see a question here from Lindsay in Portland, kind of referencing the red stuff on the threads. Well, I was just going to kind of talk about this. So in the LS application, the head bolts that Fel-Pro sells come with a pre-installed sealer, which is actually dry to the touch, which makes packaging it really easy because nothing's, you know, migrating to the packaging or the container. Pull it out of the box and basically it's ready to go. This is kind of a cured or baked on sealant that acts in two different ways. One will seal coolant that could migrate up the threads of the bolt if this particular engine had a head bolt hole that actually connected to the water. but the LS engines use what's called a blind hole, so there is no water on the threads. But the sealant also acts as a lubricant. So when we drop this guy into place, it's basically ready to start the torquing procedure. Now the only thing that's additional is to maybe add a little bit of oil or a drop of oil underneath the head of the bolt just to help reduce the friction as we're tightening this bolt against the casting. Okay, so I hope that answers your question, Lindsay. So now we can go ahead and drop in our new bolt. And in this case, you know what, I'm going to take my new bolt out because I'm going to use it here on the other side. I'm going to grab my used bolt. I want to hold this head down. I've got the other head on the other side of the engine all installed except for the last bolt. And I just want to go through the tightening procedure on these new torque to yield bolts. I'm going to buzz this down just to hold it in place. Don't worry, that sounds like a lot more torque than it is. It's just a gun spinning it down. I'm going to rotate the engine over. Okay, and now we can see that I've got all the head bolts installed here. Except this last one, this last new bolt. So I'll drop another little bit of oil on there, and we're ready to install this last head bolt into the head. Okay, so I'll go ahead and again run that head bolt down just to seat it. Okay, it's seated, and I talked about the torquing process on these new torque to yield bolts. They're basically tightened up using torque to angle, and what torque to angle means is we're actually going to tighten the bolts by degrees of rotation as opposed to using an old style clicker wrench, which would just basically click off once we've achieved a certain amount of friction between the bolt head and the casting. Not near as accurate as tightening a bolt with a torque to angle process. And so we'll go through this on this particular engine. Step one entails seating the bolt to 22 foot-pounds. And so in that case, this guy off of here, we're going to use the clicker type torque wrench to achieve that 22 foot-pounds. And that's again just the first step of the process. So we install the wrench and we put a nice even pull on the wrench. We get that first click, there's 22 foot-pounds. And why the manufacturers have you pull the bolts down to that very low initial torque value is really just to make sure everything is seated. You know, we're dealing with a multi-layer steel shim gasket with multiple layers of steel riveted together with embossed sealing beads. So we need to kind of compress everything and squish it flat before we can begin the accurate tightening process. So after seating it to 22 foot-pounds, the next step is to use, well, let me first off go over this torque angle gauge before getting the electronic torque wrench out. I mentioned torque to angle. So for a lot of you, you might question, well, how am I going to achieve maybe a 60-degree angle or an 80-degree angle if that's what the OEM specifications recommends? And you can use a tool like this torque angle gauge. These are pretty handy, they're pretty accurate, they're just a little cumbersome to use, and here's why. You basically install this between your socket and your wrench, and then you have this movable dial, which is separate from the base. And the base here has this little arm, which is a bolt stop. And you can adjust this to fit your application to where this stop rides up against something, maybe like a rocker arm bolt or another cylinder head bolt, and it prevents the lower half from rotating. And what that does is allows you to see how many degrees you're rotating your wrench when you put it on top here and connect it. So in this case, with 90 degrees being the first step, we would want to zero the tool and then pull the wrench 90 degrees, and we could exactly see when we achieve a 90-degree torque angle on the bolt. Works great, but after you move it and then reset up the stop, in this case 10 different times, it takes a little bit of time. An easier method, something a little bit more reliable, faster, and accurate is to use an electronic torque wrench. These are great tools. The first thing you do when you turn on an electronic torque wrench is it needs to go through a calibration. And it usually needs to be on a level surface. So I'll set the wrench on the table and it'll self-calibrate, and then that will allow me to basically adjust the torque value to what I need it to be. In this case, we want 90 degrees. right? So I've got it dialed into the wrench. I'll put my socket in place, come over to my bolt that I've pre-torqued to 22 foot-pounds, do the same for all the additional bolts, and I'm going to go ahead and basically put a nice even pull on this wrench, and as we approach 90 degrees with this type of wrench, you'll see some lights light up, the wrench will have an audible chime, and it will even vibrate in my hand, like it is now. So as soon as I get to 90 degrees, it's very obvious that we don't surpass it because of all the warnings this guy gives us, and it's fast and easy. So if we were torquing this head into place, unlike this mock-up engine, I would basically start from the inside and work my way out. Most manufacturers, almost all manufacturers, have a torque sequence that we would want to follow. So we would follow OEM service guidelines, print out that torque sequence, and basically tighten the bolts in stages as recommended from the inside of the casting outward. We're not doing that here because we're just installing one bolt, but I already have done stage 1, stage 2 of the tightening process, and now I'm going to finish it with an additional 90 degrees on that same bolt. So we're already set at 90 degrees. This engine is pretty easy when it comes to that of having the same specification. For the third and final step, we'll set the wrench, we'll make sure that it zeroes, okay, and we'll pull it another 90 degrees with a nice even stroke, not jerking or tugging on the wrench. And there we go, we achieve 90 degrees, and we can actually see on this particular wrench, a little bit high-end tool, the actual torque value on the fastener, which is nice information. So we're now done with tightening the bolt of a torque to yield, torque to angle tightening process fastener. I see we've got a question here from Anthony in Detroit, and Anthony asks, I have a turbo on my LS engine. Can I use a head gasket that we just installed? And that's a great question, Anthony, something we do hear a lot of as well on our tech line. This particular platform of engine that General Motors has released is a very popular platform. A lot of people retrofitting it into older cars, people retrofitting it into hot rods, people drag racing the platform. So what we've learned with this particular engine and some of these pieces and components is our stock replacement gasket and the stock replacement head bolt is good in sealing combustion pressures on this engine up to about 700 horsepower. Now there's a lot of variables factored in with that, but when you start to get into a serious application such as a turbocharged or supercharged application, you're probably going to want to step up to a performance gasket. And Fel-Pro has a broad offering of performance style MLS head gaskets for the LS engine platform. We've got high performance 4-bolt fastener gaskets, which is stock, and we also have a 6-bolt version gasket for the aftermarket blocks and cylinder heads that utilize 2 additional bolts at 6 and 12 o'clock, which really give you a good clamp load and help maintain combustion seal at really, really high pressures, such as with a turbocharger or supercharger. But something that differentiates our performance gasket as opposed to our stock replacement gasket is, first you see this is a black coated gasket. The black coating on our performance MLS gaskets is basically a high temperature coating. So it can withstand the extreme heats from a high performance engine. That's one difference. The other difference is very tough to see, but very, very important in why this is a better choice. We create a stopper layer within this gasket of these embossed beads, these embossed sealing rings that we patented laser welded, which creates a very controlled sealing area on the combustion seal. We don't do that on a stock replacement gasket. We just do that on our performance offering. But using our patented laser weld stopper technology allows this gasket to really seal double the capability of a stock replacement gasket. We have people running this type of gasket in LS platforms that are approaching 1,500 horsepower. So our 6-bolt gaskets can be over 2,000 horsepower. So definitely the best choice for you would be to use a performance gasket and probably upgrade to an aftermarket fastener, bolt or stud preferably in your application. So I hope that answers your question. And I see we've got another question up here. So today we've got a we're filming in the St. Louis TSC, where we've got a full training center shop and we've got a training center classroom. And tonight we're hosting a class for a local customer, and they happen to dial into this, and it looks like they've got a question. So the question they're asking, they're just over here, it's kind of interesting, but so they ask, how would you diagnose a head gasket that was leaking coolant or compression? Well, that's a great loaded question, by the way. And so there's a lot of different ways. Let's talk about the coolant aspect. So if we thought we had a coolant leaking head gasket where it was leaking coolant into the cylinder, which is not as easy to find as coolant leaking outside of the cylinder externally. We can usually see the trail, the trace of coolant, the staining on an external leak, but an internal leak could be very, very small, especially if the gasket's not blown, especially in situations where these MLS gaskets, you know, they don't really blow. However, they can leak or seep. So what I'm getting at is this engine could maybe just use a little bit of coolant over time. So definitely not a catastrophic failure, but just a very difficult thing to locate. So a couple of methods that are effective for that would be pressure testing the cooling system. That would be helpful. It might require removal of the spark plug. You could use to see if coolant is migrating out the spark plug hole under a pressure test. We could also, while we have the spark plug out, we could look at the firing end of the spark plug to see if there's any silicate buildup on the porcelain or the electrode, which is oftentimes also a good indicator that the engine is basically burning coolant within the cylinder. And then as far as a situation where maybe we're not migrating coolant into the cylinder this way, but we're leaking compression maybe across cylinders, that's a little bit different. You could do things like a compression test. You could do a cylinder leak down by pulling off the valve train, getting both pistons to TDC, putting air into the cylinder, and kind of looking for where that air is leaking. Like if it's leaking across here, and we had the spark plug out of the neighboring cylinder while we were putting air into this cylinder, we could certainly tell that we were leaking across this seal if the air was migrating out that spark plug hole. So a lot of different scenarios can take place when it comes to diagnosing a leaking head gasket, but those are a couple of very common practices. So I hope that answers your question. And you can get my autograph here afterwards. I'll be walking down the hall in a few minutes. So anyway, with that aside, just got one other thing to talk about. We have a few folks tuning in from Canada, and Brent wants to know, so what made you get into the automotive field? And that's a good question. I myself, I got into drag racing cars back when I was very young, 16 years old, so I was always fascinated by performance. I'm very intrigued at, you know, making something make more power, go faster, and that's kind of what led me down the road of getting into car repair. And to date, I'm still very engaged in performance and racing, more so than ever, and it kind of works with my field in keeping very engaged in changing technologies. And the LS platform happens to be one of those technologies just taking off. You know, there's a lot going on around this engine, you know, revolving around performance. So it's a great platform to talk about. I actually drag race several of these types of engines using aftermarket parts, and you can really do a lot of things with these platforms. So that's what got me into the trade. Wasn't able to ever turn back. 25 years later, here I am. So you never know what doors will open or what path you'll go down getting into the automotive fields. But so that's all I have time for tonight. If you want to see more Facebook live streams or give this video a like, and any unanswered questions that came in, we'll get to responding to those within the next 24 hours. I'm Tim Habel with Garage Gurus, and thanks for watching.